Hello and welcome back to another Algebra 1 video. Today we'll be covering lesson 2.2 extension, which is the slope of parallel and perpendicular lines. Now this is an extension of lesson 2.2, so if you haven't done so, make sure to go ahead and check out my previous video, lesson 2.1 to 2.3, which covers all three lessons from 2.1 to 2.3. Let's go ahead and begin with our very first slide. We're given here an image of a coordinate plane with two lines plotted on them. We have lines A and line B. We're given that the lines are parallel, and they're asking us what are the slopes of each line. Now, the purpose of today's lesson is to introduce you to the relationship between the slope of parallel and perpendicular lines. Let's go ahead and first find the slope of line A. Now recall that whenever you're given a coordinate plane, to find the slope, you'll go ahead and begin with your leftmost point and count the vertical change, then the horizontal change to the next solid point that you have. So I'll go ahead and circle those 2 points. For our convenience, they are already given on our graph, but if they aren't, go ahead and just locate 2 solid points on the graph. So recall that slope is rise over run. So first, count the vertical change from your leftmost point to the next solid point. In this case, we see that we're actually counting down to our next point. So since we're counting down, we know that our slope is going to be negative. So let's go ahead and count down the units. We have 1, 2, 3, 4 units down. So that will be our rise or our vertical change. And then now you count your run or your horizontal change. That would be 1, 2, 3, 4, 5, 6, 7, 8, 9 units across. So your slope for line A would be -4 over 9. Let's go ahead and do the same for line B. Locate your leftmost point, and then here's our other solid point that we're going to be counting our slope to. Once again, we're actually counting downwards toward our next point, so we know that our slope for line B is actually going to be negative. Let's go ahead and count our vertical change or our rise, which is 1, 2, 3, 4 units down. And then go ahead and count your horizontal change to hit your point, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. Now that we have the slope for each line, take a look at their slopes. Both of them are the same of -4/9. So make sure to take note of this so that you know the relationship between slope and parallel lines, which we'll take a closer look at in our upcoming slides. Let's look at another example. Once again, we're given a coordinate plane with lines A and B plotted on them. We're being asked for the slope, and we know that the lines are parallel. Now let's go ahead and begin with our leftmost point and first count the rise, then the run. So here is our leftmost point for line A, and then here is our other solid point that we'll be counting. So our vertical change will be 1 unit up, 2 units up, 3, 4, 5 units up. Notice how we're counting upwards, so we know that our slope is positive. So our rise will be 5 over our horizontal run, which will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 units across. Now, recall that you always want to express slope as a simplified fraction. So notice that you can actually reduce 5/15 by a factor of 5. So that would give your simplified slope of 1 1/3. Let's go ahead and now find the slope of line B. Here's our leftmost point, and here is our second solid point. Notice that we're counting upward for our vertical change, so line B will also have a positive slope. Go ahead and count your vertical change, which would be 1, 2, 3 units up. And then now you can go ahead and find your horizontal change, which is 1, 2, 3, 4, 5, 6, 7, 8, 9 units across. Now 3/9 is different from 5/15 and 1/3. However, notice that you can reduce this by a factor of 3. And once you do that, you get that the slope of B equals to 1/3. Once again, we can see here a common trend that the slopes of lines A and B are the same. Now, as you recall, the last two examples that we've done covered parallel lines. Now that we've looked at the slopes of parallel lines, what do you notice about the slopes of parallel lines? Now, looking at our last two examples, we saw that the slopes of parallel lines are the same. So in this case, the relationship between slope and parallel lines is that the slope of parallel lines will always be the same. Let's now look at perpendicular lines. So once again, we're given here an image of a coordinate plane with lines A and B plotted on them. We're going to find the slope of each line. I'll go ahead and first find the slope of line A, and we're given our two solid points here. I'll go ahead and begin with the leftmost point and find the rise first. So looking at the line, we can see here that we're counting upwards, so we know that our slope is positive. So we have 1 unit, 2 units, 3 units, and 4 units for our rise. And for our run or horizontal change, I'm counting 1, 2, 3, 4, 5 units across. So our slope for line A is 4/5. Let's go ahead and look at line B. These are our two solid points. Notice here that we're counting downwards to our next point. So our slope we know is going to be negative. So let's go ahead and count down our vertical change, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units down. And now we can go ahead and find our run or our horizontal change, which is 1, 2, 3, 4, 5, 6, 7, 8 units down. Now, recall that you always have to express slope as a simplified fraction. So you can actually simplify this by a factor of 2, and that would give you -5/4. So your slope for A is positive 4/5, and your slope of B is -5/4. Do you see any relationship between these two? Let's go ahead and look at another example to see if we can identify the relationship between slope and perpendicular lines. We once again have lines A and lines B. Let's go ahead and first find the slope of line A. We have our two solid points right here. And we'll go ahead and first count our vertical change or our rise. In this case, our vertical change, we are counting upwards, so we know that the slope is positive. Go ahead and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units up. And then I'll go ahead and count to our horizontal change to our other solid point, which will be 1, 2, 3, 4, 5, 6, 7, 8, 9 units across. We can go ahead and actually reduce this into a simplified fraction by a factor of 3. And that will give you that A equals 2/4. Let's go ahead and look at line B slope. Looking at our previous example, we could see that our slopes had negative signs, and they were also, well, our slopes had opposite signs, and they also were the reciprocals of one another. So what I'm predicting is that line B slope will be -3/4. Let's go ahead and see if that's true. So you can see here that these are our two solid points. We know that since we're counting downward for our vertical change, our slope is negative. So let's go ahead and first count our vertical change, which is 1 unit, 2 units, 3 units, 4, 5, 6 units down. So our rise will be -6. Now for our horizontal change, we'll have 1, 2, 3, 4, 5, 6, 7, 8 units. Now you can actually reduce this by a factor of 2, and that would give you -3/4. And my guess that our slope for B would have an opposite sign of negative and be the reciprocal of 4/3 was confirmed. So moving on to our next slide, what do you notice about these slopes of perpendicular lines? So the relationship about the slope and perpendicular lines is that they are negative opposite reciprocals, meaning that they will have opposite signs and are the reciprocals of one another. So for example, if you had a slope of 2, +2, your slope, your negative opposite reciprocal of +2 would be -1/2. And likewise, if you had a slope of -3/4, your negative opposite reciprocal would have the opposite sign, so positive, and then be the reciprocal, which would be 4/3. Let's go ahead and sum up these slope and line relationships that we learned for today. So in the case of parallel lines, they will always have the same exact slope, or M, and a different y-intercept B. So in the case of a linear equation that is in slope-intercept form, which we learned in lesson 2.3, y equals mx plus b, M will always be the same, and B will always be different. One thing to always note about parallel lines is that they will never intersect, meaning that they will never meet. They will always be their own individual lines. All vertical lines are parallel, for example. So if you recall from lesson 2.1, we learned about vertical lines. If you set up 2 vertical lines next to each other or multiple vertical lines next to each other, you'll notice that they will never intersect and that they all have the same exact slope. So they are all parallel. In the case of perpendicular lines will have slopes that are negative opposite reciprocals, meaning that your slopes will both have opposite signs, so positive and negative, and will always be reciprocals or the flipped versions of one another. So in the case of perpendicular lines, they will always meet or intersect. So they'll always meet at some point, for example, like here. And you can also look at the previous images that we looked at that demonstrated perpendicular lines. For example, vertical lines will be perpendicular to horizontal lines, and their point of intersection will be right there. And the intersection of perpendicular lines will always form a right angle or an angle measuring 90 degrees. So in the case of perpendicular lines, you'll see that they're actually able to form a right angle at their point of intersection. And this will be true of any 2 perpendicular lines. That is it for today's lesson. Thank you so much for watching, and as always, all information regarding additional practice problems, tutoring inquiries, and references will be linked down below in the description box.